5.5 slope of a line. And it's pretty easy because it's taking off right from yesterday, because we were finding the rate of change yesterday. The rate of change is also known as the slope of a line. All right? Yesterday we were finding out unit rates. How much per lawn, how much per minute. That was the rate of change. But also you use that to find a slope of a line. Whenever you have an equation, m represents the slope in a line. So if you have y equals mx, this is the slope of the line on the graph. M always represents the slope. And then yesterday when we did when we were talking about rate of change, we talked about the change was an increase, like the price went up or the water level went up. Decrease, the amount of flour decreased in the container as you cooked a batch of cookies. All right. Today we refer to these on the graph as a positive slope and a negative slope. And just like on your worksheets today, if your graph went like this, you had a positive answer. Like on the ones that we did that had the cookies, it went down, it decreased, so you had a -2. Anytime it's negative, decreasing, your answer is negative. Add these to your notes as well, please. Horizontal line and vertical line. That goes with the zero slope, and that goes with undefined slope. A positive slope is always a function. A negative slope is always a function. A zero slope, which is a horizontal line, that is always a function. And here's examples of it, and we'll go over these in detail in a minute. But this undefined slope, that's a vertical line, that is never a function. So we can answer it before we even draw our lines on here for examples here in a second. We can answer this question. Which line does not represent a function? Which one of these is not a function? An undefined slope. And an example of an undefined slope is anytime it's just x equals a number. That's undefined. Or sometimes you'll end up with a slope, it'll be like 7/0, or maybe a -4/0. Anytime the 0 is on the bottom, is that possible? No, you can't divide by 0. That's not possible. Alright, so let's just add a couple lines to our graph to indicate what this would look like. Now, positive slopes. See our number line up here above the board? You have your number line. And say this is 0, right here. And here you have 1, 2, 3, you have all the positive numbers. Here, -1, -2, -3, all your negatives to the left. Well, if I want to draw a positive slope, I can run it, say I go right through the origin. This one has direct variation because it's going right through the origin. That's a positive slope. This is a positive slope. This is a positive slope. So draw those on your worksheet as well. Those are all just a couple examples of positive slopes. How do I know? Well, it goes to the right and up. It increases, right? If you go from the bottom up to the right, it increases. But also the top, see the top of your line? Does that point towards the, if you're standing at the 0, would this point towards the positive side of the number line, or would it point to the negative? It points to the positive side of the number line too, doesn't it? So you know you have a positive slope. If you start at the bottom and it goes up, it's positive. So then, obviously, the next one's negative. If it went through the origin somewhere, it would be going this way. Or maybe this way. Or maybe that way. Those are all examples of negative slopes. See the top of your line? Is that pointing? If this was 0, I always say, look at the origin, your y-axis. If that's 0 on the number line, are the tops of your lines pointing toward the negative or the positive side? The negative. So these are all negative slopes. So you always want to make sure your answer is a negative. All right? Here, for a zero slope, a zero slope is a horizontal line. So let's graph this one. Say y equals a -7. Y equals a -7. So on your y-axis, you'd find the -7, which might be like right there. And then you intersect it right there. That is the equation y equals a -7. If we go to the 2, the y equals 2 on the y, you find the 2, and you draw a horizontal line right through it. Are those functions? Yes, because it doesn't fail the what test? The vertical line test. Obviously it doesn't, it's a horizontal line, so those are all good to go. This one, so if x equals a -7, on my x-axis, say -7 is over here, right there. X equals 2, on my x-axis, maybe it's about right there. What kind of lines are those?
Vertical.
Those are vertical lines. So obviously, what test does it fail? The vertical line test. It is a vertical line. Now, what kind of slope does this have? 0 over here. The horizontal line always has a 0 slope. Obviously, think of it. If you're a skier and you're standing on this slope, la la la, how much fun are you going to have? None. Where are you going to go? Nowhere. This is fun, right? 0 slope on a ski slope, you go nowhere. 0 slope on a horizontal line. Now, if you're a kamikaze skier and you go to the top of this vertical line and you decide to jump off and ski down, do you know where you're going to land? No, it's not going to be a pretty landing, but you'll land. But wherever you land down here, it's going to be undefined. You're not going to have a clue to where you're going to land down here. All right, so that slope is undefined. Okay, get these into your notes, please. And this should be easy. A right triangle, we did that in the Pythagorean theorem unit. That was one of you guys' better tests. Deals with a triangle with a right 90-degree angle. Horizontal lines. Okay, yesterday when we did rate of change, we did the vertical change over the horizontal change. Well, rise over run today is what it's called. Your horizontal line is your run. Your vertical change is your rise. And I like to add these little graphs over here so you know. Rise over run, well, you have rise over run. So this direction on the top, the run on the bottom. If the rise goes up, it's positive. If it goes down, it's negative. How about if you move to the right? Is that positive or negative on the graph? Good. And so if you move to the left, it is negative. So these are the steps we're going to use to solve the next ones, where you're going to calculate the slope of a line if I give you a graph. First thing you have to do is choose 2 points on the line, identify the vertical change, identify the horizontal change, and then write the slope as a fraction, and this is huge, in simplest form. It has to be simplified or you'll lose points, okay? I'll bring that back so you can copy them. Okay, calculate the slope of the line. Draw a right triangle between 2 points. Let's pick 2 points first. Remember, we always want to pick one on an intersection. So what looks like a good one? Pick a point for me. 4 and 1. 4 and 1. I like it. Okay? So one of my points is 4 and 1. What's my other point that I'm going to use? 0 and 0 and what? -3. Great. Now we need to make a right triangle. You can start from here and go over and make it this way if you want. Or you could go here and you can make it on this side if you want. It doesn't matter because we'll end up with the same answer in the end. But for practice right now, let's just all do the same one. We'll go this way and this way. All right? So what is my vertical change? What is my vertical change here? How many did I change? If I'm going to start here, actually, can I just start back here again? Because I like to just kind of go over this way. What is our horizontal change? How did I go? 1, 2, 3, 4 to the right. So is that a positive or a negative if I go 4 to the right? I went a positive 4. Then I went up how many? 1, 2, 3, 4. So basically my slope, which represents m, my slope m equals 4 over 4. Is that simplest form? What is the simplest form then? 1 over 1. I wouldn't count it wrong, but what's even a better answer? 1. So slope, my m equals 1. And is it a positive slope? Is this going in a positive direction? Why, yes it is. So we look like we did a pretty good job. Let's try another one. Give me a point. 0 and 7. I like it. 0 and 7. One more. 1 and 3. Another good one. 1 and 3. Now let's do it the other way. Let's start at the top and go to the bottom one. So we'll go here, make our right triangle. So vertical. If I start here and go this way, what's my vertical change? I went down how many? 1, 2, 3, 4. So I went down 4. Do I leave it like that? What does it mean if I went down 4? It's a negative, so that means a negative 4. Then I went to the right 1 from here to here. So is that a positive or a negative 1? Positive 1. So now I'm going to have a negative 4 over 1. M equals a negative 4 over 1, or better yet, M equals what? This is correct, but better yet, just your negative 4. Your slope, M equals a negative 4. Is this a negative line? If this is 0 on my number line, does it point to the negative end? It does. So we have to have a negative answer then. My slope is negative. All right, I'll give you a couple seconds to come up with this one and hold up on your boards what your slope is. What is your final answer for M equals? What does M equal on your boards, please? A lot of good answers. I'm seeing positive 3, I'm seeing a positive 1/3, I'm seeing a negative 1/3. So, first of all, is our answer going to be positive or negative? Positive, because this is going in, if this is 0, the top of this is going pointing towards the positive end. So I know that my slope is going to be positive. Positive what? Well, what 2 points did you use? You could have used 0 and 0, and you could have used 3 and 1. Now again, it doesn't matter. You could have picked this over here. You could have used 2 and or 6 and 2. It's up to you. They're still going to be the same answer. Right, going from here, my horizontal change. How many did I go? To the right 3, which is what? To the right 3, is that a plus or a minus 3? Plus 3. And then I went up 1, so is that a plus or a minus 1? Plus 1. So now I have 1/3. 1 over 3. My slope is a positive 1/3. So I could extend my line. I could go right 3, because this is rise over run. Rise over run. So you go right 3, up 1. Put your pencils on your graph and follow this and extend your line. Right 3, up 1. Or we can go backwards. Make these, if these were both negatives, does that make it still a positive? Yeah. Yes. So you could start back here and go, instead of right 3, up 1, you can go left 3, a negative 3, and minus 1. Left 3, down 1. You can extend your line just by using your slope. Now, I give you the 2 points instead of the graph, so now we have to graph it. So put these 2 points on our graph. First one is -3 and 5. A -3 and a +5. and we have 4, -2. Use the straight edge, the side of your calculator, to make your line. All right, now what do we have to do? Since we made our line, now we have to use those 2 points and make a what? A right triangle. So you could go this way and down or this way and down. It doesn't matter. Right, so we have to have the vertical change over the horizontal change. Rise over run. So what is my vertical change? So we have to pick a point. We'll start from the bottom and go up. First of all, is this a positive or a negative line that we just drew?
Negative.
Has a negative slope, so m equals, it better be negative, because this is a negative slope. A negative what? Well, from here to here, how many did I move? 1, 2, 3, 4, 5, 6, 7. To the left, so that would be what? A -7. How many did I go up? 1, 2, 3, 4, 5, 6, 7. What is that simplified? 7 over -7. So a positive divided by a negative is a negative. A negative what?
-7.
Negative. That would equal, because 7 goes into here once, I'd have a +1 over a -1. A -1. Slope is a -1. So that means I could extend this, right 1, down 1, right 1, down 1. I could keep going. Put all my points. I could keep going up this way to make my line go. All right, let's do B. I'm going to give you a few minutes to put the points on your graph, draw your line, and then tell me what your slope is. What does m equal? What does m equal? And you'll want to pause the video and do this. So your graph should match mine. What kind of a graph is it? Positive or negative? Positive or negative?
Negative.
It's a negative graph, so we know your slope has to be negative. Now let's figure out rise over run. Let's see, make my right triangle. Oops, went a little too far. So what is my rise over run? What's my vertical change? From here down to here. 1, 2, 3, 4. A -4 over 1, 2. A +2. Simplified, we know that it's negative. A negative what? 2 goes into here once. 2 goes into here 2. A -2 over 1, or better yet, just a negative what?
2.
Excellent. Just a -2. All right, now these, the last part of our notes, let's skip this one for time-wise. Okay? I'm going to skip this one due to time. All right, now this one, they just, like I told you, you can just plot a line by giving you a slope. Take your pencil and make a dot anywhere you want on this graph. Go ahead, just make a dot, make a point, anywhere you want. I'll start here. All right, now from our point, we want a graph that's going to represent a line that has a slope of 3. Well, how do I know what to go from? 3, you turn it into a fraction, 3 over what? 1. So that means rise over run. Vertical, horizontal. So from your point, I'm going to run a +1. So you're going to go over here, +1, and rise a +3. 1, 2, 3. Okay, so from your dot, you go right 1, up 3. 1, 2, 3. And do it again. Right 1, up 3. 1, 2, 3. And then I run out of room. I don't know if you guys did, but I did. So I'm going to go back to my original point here, and I'm going to go backwards. Instead of right 1, up 3, I'm going to do what? Left 1, down 3. Left 1, down 3. See how it extends my line? Now that has a slope of a positive 3, that line. All right, let's practice another one. Now, just so our lines will look alike, let's everybody start at the origin, okay? And on your worksheets, let's just start on the origin. You can start, as you just noticed, you can start anywhere you want. But just so we have the same line right now, everybody start making their point. We want a line that has a slope of a negative 2/3. So let's start at the origin. I'll give you a couple seconds to make your line with a negative 2/3 of a slope. Now, either assign that negative to the top or to the bottom. So you can start out with a -2, preferably. Usually you have it assigned to the top number, but it would also work if you go 2, when we go backwards, 2 over a -3. First of all, it's negative, so I hope that your line that you made is pointing somewhere in the negative direction up here, or you goofed. So we'll start going this way. That means I'm going to go to the right 3, and then what does this mean? Down, how many? What's my, yep, no, my vertical change is what? Down how many? So I could start at the top, I could go down 2, right 3, down 2, right 3, or even if I did the bottom first, right 3, down 2. See how you still end up at the same place? So, right 3, down 2, right 3, down 2. But I gotta get some over onto this side, so I go backwards. Instead of right 3, down 2, I go what? Left how many? Left 3 and up 2. Left 3, up 2. And there I have all these points to make a nice line that has a slope of a -2/3. Just use your calculator for a straight edge to infinity and beyond. All right, time-wise, there we go. We're going to skip that last one. Pages 5 through 7, 5, 6, and 7, due for tomorrow.